Good morning, students. This is next topic, next chapter. Good morning, students. This is next chapter in organic chemistry part, that is aldehydes and ketones. We know already what is aldehydes and ketones. We just revise about the definitions of aldehydes and ketones. If the carbonyl group is attached to two hydrogens, or are one hydrogen and one carbon or two carbons are called carbonyl compounds. This is very important. If the carbonyl group means C double bond O group. Carbonyl group means C double bond O. This is called carbonyl group. If that group is attached to two hydrogens or one carbon and hydrogen and two carbons. If this carbonyl group attached to two hydrogens or one carbon and hydrogen or two carbons, then these compounds are called carbonyl compounds. Now these carbonyl compounds are classified into two types. They are aldehydes and ketones. What is aldehydes? If the carbonyl group is attached to two hydrogens or one hydrogen and carbon, they are called aldehydes. That means see, these two examples comes under aldehydes. If the carbonyl group is attached to two hydrogens or one carbon and hydrogen, those are called aldehydes. Then this is ketone. So what will be the definition? If the carbonyl group is attached to two carbons, that is called ketones. So what is the definition? If the carbonyl group is attached to two carbons, then it is called ketones. Examples are C11OR. That means in this R, carbons are present along with hydrogens. R is what? Alkyl group. So this carbonyl group is attached here with one carbons. Here also this carbonyl group is attached to benzene rings of carbons. So these are also called ketones. Next, aldehydes and ketones are functional isomers. The general formula for carbonyl compounds is CnH2nO. Carbonyl compounds nothing but aldehydes and ketones. What is the point here? Aldehydes and ketones both are functional isomers. Why? C. CH3, CH2, CHO. This is aldehyde because if CHO is present, that is aldehyde. CH3, C double bond O, CH3. This is ketone because this carbonyl group attached to two carbons. This is aldehyde, this is ketone. What is the molecular formula for this one? Molecular formula. That means how many carbons? 1, 2, 3. 3 carbons. Here how many hydrogens? 3 plus 2, 5 plus 1, 6 hydrogens, 1 oxygen. In this case also molecular formula is same. Check it. How many carbons? 1, 2, 3. How many hydrogens? 3 plus 3, 6. 1 oxygen. So both are having same molecular formula, but functional groups are different. Here functional group is aldehyde, here functional group is ketone. So both are functional isomers. Then what about the general formula? General C3H6O. That means double the number of hydrogens compared to carbons. Double the number of hydrogens. So general formula is CnH2nO. So that is the general formula of carbonyl compounds is what? CnH2nO. Next, IUPAC name of aldehydes. IUPAC name of aldehydes is what? Alkanols. Ethanol, propanol, butanol, like that we give name for aldehydes, IUPAC name. So that general IUPAC name for aldehydes is what? Alkanols. Then what about ketones? Alkanones. Alkanone is butanone, propanone, pentanone. Like that we give IUPAC name for ketones. So the general IUPAC name for ketones is what? Alkanones. In case of aldehydes, alkanols. Next topic, nomenclature of aldehydes and ketones. Example, HCHO. Here HCHO, this is formaldehyde. This is formaldehyde. Its IUPAC name is what? Methanol. Methanol, because only one carbon is present. If CHO is present, secondary suffix is what? Al. So methanol. Next, CH3CHO. Its common name is acetaldehyde. Acetaldehyde, CH3CHO. HCHO is formaldehyde. CH3CHO is acetaldehyde. So its IUPAC name is what? Ethanol. Ethanol. This is the IUPAC name for acetaldehyde. Next here CH3, CH2, CHO. 3 carbons. So, propionaldehyde. This is common name, not IUPAC name. Propionaldehyde. But IUPAC name is what? Propanol. Because 3 carbons. Prop. Ane. Why we should mention ane? Because between carbons, single bonds are present. Ane. CHO is present, then secondary suffix is what? All. Propanol. Next, in this case, CH3, CH2, CH2, CH4, 4 carbons. Butyraldehyde. This is common name. Butyraldehyde. Then what about its IUPAC name? IUPAC name is butanol. 4 carbons are there. See, this is, if 2 CH3 present on CH, then its IUPAC, its common name. Its common name is what? Isobutyraldehyde. Iso means what? If 3 carbons present on, if 2 carbons present on CH, that is iso. Butyraldehyde 4 carbons, 1, 2, 3, 4. So isobutyraldehyde. Its IUPAC name is, this is the branch, 2-methyl propanol. 2-methyl propanol. That's it. Next, in this case, it is what? Valeraldehyde. If 5 carbons are present, then its common name is valeraldehyde. Then its IUPAC name is pentanol. This is isovaleraldehyde. Here IUPAC name is what? Number given from this side, 1, 2, 3. So the third carbon gets substituted. That is which one? Methyl. So 3-methyl butanol. That's it. Next, CH3CO CH3. CH3CO CH3. Its name is acetone or dimethyl ketone. Dimethyl ketone or acetone. This is common name. Then what about IUPAC name? Propanone. That's it. Propanone. Next, here, in this case, common name is what? See, ethyl, methyl. Both two different alkyl groups present around carbonyl group. So its common name is ethyl methyl ketone. Ethyl methyl ketone. That is common name. Then what about IUPAC name? Number given from right side. Because if you give number from this side, left to right, this carbonyl group gets third position. Because this is functional group. So we have to give number from right side. 1, 2, 3, 4. So its name is what? But single bonds ane, one. That is present at second carbon. So its IUPAC name is what? Butanone 2. But in this case, there is no chance of butanone 1. Butanone 1. So you can mention simply butanone. Butanone 2 or butanone. Both are correct. Next here. CH3, CH2, that is ethyl. Here also CH2, CH3 ethyl. That means diethyl ketone. Then what about IUPAC name? If you give number from either of the side, then this carbonyl group gets a third position. So its IUPAC name is what? Pentanone 3 or 3-pentanone. Pentane 3. In this case, we have to mention number because there is a chance of pentanone 2. So we have to mention pentanone 3 number. We should not mention pentanone simply. Next, see, this is propyl. This is methyl. So methyl N-propyl ketone, that is common name. Then what about IUPAC name? Pentanone 2. Because we give number from right to left. Next, this is isopropyl methyl. Both are two alkyl groups are there. Propyl, methyl. Which comes first as per alphabetical order? This comes. So methyl isopropyl ketone. Methyl isopropyl ketone. See, that is common name. Then what about IUPAC name? We give number from right to left. 1, 2, 3. So 3-methyl 2-butanone. 3-methyl 2-butanone or butanone. Next, some more examples. See, this is isopropyl group. This is also isopropyl group. So diisopropyl ketone. That is common name. Then what about IUPAC name? If you give number from either of this side, then this carbonyl group gets a third position. So 2,4 dimethyl pentanone 3. 2,4 dimethyl pentanone 3. Next, in this case, see here, two functional groups are present, ketone group and aldehyde group. If two functional groups are present in a given organic compound, then one group gets higher priority and other group gets lower priority. So among ketone and aldehyde, which gets more priority? CHO. We discussed that point in class 11. So this is more priority functional group. This is least priority functional group. Automatically this is considered as prefix. If CO is considered as prefix, its prefix name is what? Oxo. We have to give number from which side? Right to left. 1, 2, 3. So 3 oxo butane all. 3 oxo butanol. Here also two functional groups are present. Again same functional group. Again we have to give number from right to left. So what is the name? 2 methyl 3 oxo butanol. That's it. So this is about nomenclature of carbonyl compounds, nothing but aldehydes and ketones. Now we discuss about preparation methods of aldehydes and ketones. First we discuss about preparation methods of aldehydes, later we discuss about preparation methods of ketones. Preparation methods of aldehydes. First preparation method, oxidation of primary alcohol. We have seen already this reaction in alcohols. When primary alcohols undergoes oxidation in the presence of KMnO4 or K2Cr2SN, then we get acids directly. First we get aldehydes, later we get acids. So we should not take K2Cr2O7 or KMnO4 because we get acids. But if you take PCC, pyridium chlorochromate, this is a weak oxidizing agent, then it can convert primary alcohols to aldehydes only. It cannot convert aldehydes to acids. So this is best oxidizing agent to prepare aldehydes from primary alcohols. Next one, dehydrogenation. Dehydrogenation. This reaction also we have got in alcohols. When primary alcohols undergoes dehydrogenation in the presence of copper at 300 degrees centigrade, then also we get aldehydes. Next, hydration of alkynes. Hydration of alkynes. We have got this reaction in class 11. See, this is acetylene. When acetylene reacts with water in the presence of mercuric sulfurate and sulfuric acid, then we get enol, phenyl alcohol or enol. How one H is added here and one OH is added here, then triple bond converted to double bond. This enol form again undergoes tautomerism. Tautomerism means what? Tautomerism means this ene form converted to one form. Ene form converted to one form. That is tautomerism. See, tautomerism means ene form converted to enol. Ene form converted to keto form or keto form converted to ene form. Not enol. Enol form converted to keto form converted to enol form. That is tautomerism. This is enol. Which one? CH2 double bond CHOH. This is enol. How can we say that? Because double bond carbon having OH, so that this is enol. When this enol form immediately converted to keto form. How? This is the given this is the compound we have got in the reaction, CH2 double bond CHOH. Then when this hydrogen comes to this position, then this double bond shifted to here. Then CH2 becomes CH3. Then double bond becomes single bond. Then what is remaining? CHO. Here what is the point? Between carbon and oxygen, double bond O is present, so that it is keto. Between carbon and O, here double bond O is present. Double bond is present, so that it is called keto. Finally, enol form is converted into keto form. So what finally we got which one? Aldehyde. This name is what? Acetaldehyde. CH3CHO name is what? Acetaldehyde. Next, ozonolysis of alkenes. This also we have got in class 11. Ozonolysis. When we take ethylene, when it reacts with ozone, then ethylene ozonide is formed. This is unstable. When this compound treated with zinc in the presence of H2O, then we get two formaldehyde molecules along with H2O2. Two formaldehyde molecules along with H2O2. We discussed this reaction already. These bonds will be broken when it is this compound treated with this one. Then this is CH2O, this is CH2O. That means two CH2Os come and this oxygen combines with H2O. Finally, it forms as H2O2. Like that, we get aldehydes. This is formaldehyde. What is the shortcut here? When double bonded compounds treated with ozone, when double bonded compounds treated with ozone, then that double bond completely broken. One oxygen come here, one oxygen come here. That is the product. That is the shortcut of ozonolysis of alkenes. Next, Rosen-Munz reduction. Rosen-Munz reduction. This is also very important because this is one of the named reaction. In this reaction, we take CH3COCl. Its name is acetyl chloride. Reduction means addition of hydrogens. When this compound reacts with hydrogen in the presence of palladium barium sulfate and quinoline, palladium barium sulfate in quinoline, then we get acetaldehyde. How? See, CH3COCl. When this compound treated with hydrogen in the presence of palladium barium sulfate and quinoline, then this bond will be broken. This side hydrogen come, this side hydrogen come. Finally, we get what? CH3CHO. That means acetaldehyde. C plus HCl. Here some points are there. That is, in the above reaction, quinoline acts as catalytic poison or negative catalyst. Negative catalyst means which reduces the rate of reaction. Positive catalyst means which increases the rate of reaction. In this reaction, quinoline acts as negative catalyst. Why? If it is not taken, immediately this aldehyde again undergoes reduction. Because this palladium barium sulfate is a strong reducing agent. So it immediately reduces product further time. So to prevent that reduction, we have to take quinoline. Quinoline acts as a negative catalyst. Next, one more point. This palladium and barium sulfate, these are called Lindlar's catalyst. The mixture of palladium and barium sulfate is called what? Lindlar's catalyst. So when acetyl chloride undergoes reduction in the presence of Lindlar's catalyst, then we get which one? Acetaldehyde. Next preparation method, Stephen's reduction. Stephen's reduction means when this compound, which compound? CH3CN. That means CH3CN means what? Methyl cyanide undergoes reduction in the presence of tin chloride and HCl. Then we get this compound. That means here also addition of hydrogen takes place, nothing but reduction. Now this compound undergoes hydrolysis. Then hydrolysis takes place like this. Two bonds will be broken. Then NH side H2 comes and CH side O comes. H2O. Bond broken like this. H2 comes to this side and O comes to this side. Then finally we get CH3CHO along with NH3. Next, reduction of cyanides with Dibol H. Dibol H means diisobutyl aluminum hydrate. Diisobutyl aluminum hydrate. That is also one of the reducing agent. Here reduction takes place in the above reaction. Reduction takes place in the presence of SnCl to HCl. That is Stephen's reduction. That is also named reaction. Here reduction takes place in the presence of Dibol H. When same type of reaction takes place, same hydrogen addition compound formed, it also undergoes hydrolysis. What is the difference? Reducing agents are different in the above two reactions. So that is all about preparation methods of aldehydes. Now preparation methods of which one? Ketones. If you understand the preparation methods of aldehydes, then automatically you will be understood about preparation methods of ketones. In case of aldehydes, which we are taken primary alcohols. When primary alcohols undergoes oxidation in the presence of PCC, then we get which one? Aldehydes. In this case, we have to take secondary alcohols, then we get ketones. Same reagent. Which reagent? PCC. Next, in that case, we have taken primary alcohols for dehydrogenation. Here we have taken secondary alcohols for dehydrogenation. When secondary alcohols undergoes dehydrogenation, the presence of copper at 300 degrees centigrade, then we get ketones. That is about the manufacture of ketones from secondary alcohols. Next one, from acyl halides. Acyl halides, nothing but acyl chloride, CH3COCl, nothing but RCOCl. When this compound treated with dialkyl cadmium, R2CD means dialkyl cadmium, then what happens? This is cadmium removes along with the chlorine, then CdCl2 is formed as byproduct, then which is remaining? Ketones. That means these two R groups going to attack here, then ketones are formed. So this is about preparation, one of the preparation methods of ketones from acyl halides. Next one, from Grignard reagent. This is very important reaction. All Grignard reagent reactions are very important. See, Grignard reagent means what? Alkyl magnesium halide. Alkyl magnesium halide is called Grignard reagent. When Grignard reagent reacts with alkyl cyanide, then we get ketones. I show that reaction here. You see carefully. RMgX, for example CH3MgCl. When this compound reacts with CH3CN, in this CN, triple bond is present between carbon and nitrogen. CH3MgCl plus CH3 single bond, triple bond N. Then what happens? This is positive part, we know that. This is which part? Negative part. This negative part come and attack here. Why? Compared to nitrogen, carbon having less electronegativity, so this nitrogen acquires partial negative charge, this carbon acquires partial positive charge. To that positive charge, this methyl group comes and attack here. Finally we get which one? CH3. This triple bond becomes double bond because addition takes place. NMgCl. Why MgCl comes? Because this is negative charge. To that negative charge, this positive part come. This is unstable. It undergoes which one? Hydrolysis. Then this bond will be broken. This double bond will be broken. This side H2 come. This side O come. We get which one? CH3 C double bond O CH3. That means this part plus NH2MgCl. This is ketone. Like that we can prepare any ketone from Grignard reagent. Here one more important point is there. That is, I show the reaction first. CH3MgCl. When it reacts with the HC triple bond N, that means hydrogen cyanide, similar type of mechanism takes place. That means which one? CH3 double bond N MgCl. When it undergoes hydrolysis, this bond will be broken. This side O come, this side H2 come. Finally, HCCH3 double bond O plus NH2 MgCl. This is byproduct. No need to remember about this one. We discuss about this one. This is what? CH3 CH1, nothing but acetaldehyde. So what is the point here? When Grignard reagent reacts with the hydrogen cyanide, then we get aldehydes. But when it reacts with any cyanide other than hydrogen cyanide, then we get ketones. This is very important. When Grignard reagent reacts with hydrogen cyanide, then we get aldehydes. But when it reacts with any cyanide other than hydrogen cyanide, then we get ketones. So this is all about preparation methods of ketones. In next video we will discuss about chemical properties of aldehydes and ketones. Thank you.